Good day, sir. We are from Group 6 and this is our group member. Let me introduce myself. My name is Chai Carmen, matrix number 293835. The question 1A asks us about what is the difference between a null hypothesis and an alternative hypothesis. A null hypothesis is a statement about the value of a population parameter developed for the purpose of testing numerical evidence, while alternative hypothesis is a statement that is accepted if the sample data provide sufficient evidence that the null hypothesis is false. Next, question 1b asks about what is the difference between a 1-2 test and 2-2 test. 1-2 test will only have one critical region, whereas 2-2 tests will have two critical regions.
A p-value is the probability of observing a sample value as extreme as or more extreme than the value observed, given that the null hypothesis is true. A hypothesis regarding the weight of newborn infants in the child hospital is the mean is 6.6 pounds. A sample of 7 infants is randomly selected and their weight as births are recorded as 9.0, 7.3, 6.0, 8.8, 6.8, 8.4, and 6.6 pounds. What is the decisions of a statistical significance change in average weight at birth at a 5% level of significance? Step 1 is list down the H0 and H1. H0 mu is equal to 6.6, H1 mu is not equal to 6.6. Step 2 is list down the alpha equals to 0.05. Step 3 is use t distribution since standard deviation is unknown. Step 4 is sketch a graph with the critical value negative 2.447 and 2.447. We reject H0 if computed t less than negative 2.447 or computed t more than 2.447. As we know, mu is 6.6, x bar is 7.56, s is 1.18, and n equal to 7. Then we sub into the formula, then we get 2.15. 2.15 fall outside the rejected area. H0 is not rejected. We conclude that the statistic significance is not changed in average weight 6.6 pounds as birth. 5 steps to perform hypothesis testing is: first, state the null and alternative hypothesis. Second, select a level of significance. Third, identify the test statistic. 4, formulating a decision rules. 5, take a sample, arrive the decisions which do not reject the H0 or reject H0 and accept the H1. Breaking up. Respond insurance collector data on seatbelt use among UN driver of 1,000 driver 25 until 34 years old. 27 say that they broke up, whereas 330 of 1,100 driver 45 until 64 years old said that they did. At the 0.1 significance level, do the sample suggest that there is a difference in seatbelt use between driver 25 until 34 years old and those 45 until 64 years old? Step 1, we will list down H0 and H1. H0 is pi1 equal to pi2. H1, pi1 is not equal to pi2. Step 2 is alpha equal to 0.1. Step 3, we will use Z distribution. Step 4, we will sketch a graph with the critical value negative 1.64 and 1.64. We reject H0 if computed Z less than 1.64 or computed Z more than 1.64. Then we calculate P1 equal to 0.27, P2 equal to 0.3, and PC equal to 0.29. Then we sub it into the formula, then we get negative 1.51. Negative 1.51 fall outside the rejected area. H0 is not rejected. We conclude that the seatbelt of driver 25 years old is not different than those 45 until 64 years old. List below is the rate of return for 1 year for a sample of 8 Islamic mutual funds that are classified as taxable money market funds. At a 0.01 significance level, can we conclude that the mean rate of return is less than 6%? Step 1, we will list out H0 and H1. H0 is mu more than 6.6, H1 is mu less than 6.6. Step 2, alpha is equal to 0.01. Step 3, we will use t distribution since standard deviation is unknown. Step 4, we will sketch a graph with a critical value negative 2.998, We reject H0 if computed t less than negative 2.998. As we know, x bar equal to 5.64, s equal to 5.64. Then we sub into the formula, then we get negative 1.64. Negative 1.64 fall outside the rejected area. H0 is not rejected. We can conclude that the mean rate of return is not less than 6%.
Next, question 2D. The Ministry of Human Resources wanted to know whether the mean salary of workers in the fast food industry was larger than that of the restaurant industry. To investigate, the ministry collected the following information on the amount earned last week by a sample of workers in the fast food and restaurant industry. At the 0.1 significant level, can we conclude that the mean salary are greater for the fast food workers than the restaurant workers? And what is the p-value? Step 1, we state that H1 mean population for fast food workers is larger than the mean population for restaurant workers, while HO mean population for fast food workers smaller and not equal to mean population for restaurant workers. Our significant level is 0.1, and we use t-test as the standard deviation for population unknown. From the t-table, we found that the critical value is 1.363. The n for fast food workers is 6, the mean is 142.50, and the standard deviation is 12.24. While the n for restaurant workers is 7, the mean is 130.2, and the standard deviation is 15.79. At last, we found that the t is 1.55. Since 1.55 falls inside the rejection region, HO is rejected. We can conclude that the mean salary for fast food workers are greater than the restaurant workers. Next, the p-value is between 0.05 and 0.1. Furthermore, question 3a. An investigation of the effectiveness of a training program to improve customer relationship include the pre-training and post-training customer survey. To compare the difference, they computed the post-training survey and to compare the difference, they compute post-training survey score, pre-training survey score. 7 customers were randomly selected and complete both surveys. For a 0.05 significant level, what is the decision regarding the hypothesis that the training was effective in improving customer relationships? Step 1, we state that the H1 mean population is larger than a 0, while HO mean population is smaller and not equal to 0. Our significant level is 0.05, and we use t-test as the standard deviation for population is unknown. From the t-table, we found that the critical value is 1.943. The mean for the difference between post-training survey and the pre-training survey is 2, while the standard deviation is 2.08. At last, we found that the t is 2.54. Since 2.54 falls inside the rejection region, HO is rejected. We can conclude that the training was effective in improving customer relationship. Lastly, question 3b. A number of minor automobile accidents occurred at the various high-risk intersections in 13 countries despite traffic lights. The traffic department claims that a modification in the type of light will reduce these accidents. The country commissioners have agreed to a proposed experiment. 8 intersections were chosen at random, and the light at those intersections were modified. At the 0.1 significant level, it is reasonable to conclude that the modification reduced the number of traffic accidents. Step 1, we need to state that H1 mean population smaller than 0, while HO mean population larger and not equal to 0. Our significant level is 0.1, and we use t-test as the standard deviation for population is unknown. From the t-table, we found that the critical value is negative 2.998. The mean for the difference between after modification and before modification is negative 2.5, while the standard deviation is 2.9277. At last, we found that the t is negative 2.42. Since negative 2.42 fall outside the rejection region, HO is not rejected. We can conclude that the modification does not reduce the number of traffic accidents. That's all from our group. Thank you.